Hi, welcome back to Imperium Learning. Now in this video I'm going to be showing you how to estimate and interpret a GARCH 1-1 model using Eviews. So just very quickly before I go on to Eviews, I just want to explain the main difference between ARCH models and GARCH models. The key difference lies in the conditional variance equation of the GARCH model. So if we look at the difference between an ARCH 1 model and a GARCH 1-1 model, we can see right here that the first two terms are exactly the same for both. The only difference is here, where the sigma square, where the variance of the error term is also captured or predicted using the variance value in the previous time, the variance value of the error term in the previous time period. Now, the question is, why does that make it a better model than an ARCH 1 model? Well, the reason it does is because it better captures volatility clustering in financial asset returns data. And so what that means is if the volatility is high in the previous time period, then the forecast going forward will predict a large amount of volatility. So that's really important to bear in mind. The conditional variance equation of the ARCH 1 model doesn't have that capability. So that's why the GARCH 1-1 model tends to be a better choice of model when you're trying to model the volatility of the returns of a financial asset. So now I'm just going to move on to Eviews. I'm going to show you how to estimate a GARCH 1-1 model. So you go on here, make sure that you click on Arch. And so straight away we can see there's a 1 and a 1. We're going to be estimating a GARCH 1-1 model, so we don't need to change anything there. Then we type in our conditional mean equation, which is just the same as our ARCH 1 model. So we type out our ARMA 2 specification. And then we go on to options. We make sure that our optimization method is on Eviews legacy, like so. And then we click on OK. So there it is, the estimation output results for a GARCH 1-1 model. I actually want to go onto my PowerPoint presentation again. Because I think this makes it easier to kind of present the kind of things that you should be talking about when you're analysing it. Again, a lot of your analysis should be focused on the variance equation rather than the mean equation. As you can see, by the way, the p-values for our variables are basically all insignificant at the 5% level at this when you're using this model. That doesn't mean that you should try chopping and getting rid of all the various terms of your conditional mean equation. In fact, you should probably keep it consistent throughout, so you should just keep it the way it is. But your main focus should be on the variance equation. So just a few things to discuss. First and foremost, just comment on your ARCH and GARCH terms being significant at the 5% level, because obviously in my case the p-values are 0.000 in both cases. And then also a second thing you can talk about is that the sum of the coefficients, now look here, 0.1488 plus 0.8258, or 59 actually if you round up, if you add those together, the sum of those two coefficients is very close to 1. And so what that means is that that any shocks that are experienced by the conditional variance will be highly persistent. And finally, if you look at this, the GARCH term, focus on the fact that it's significant at the 5% level, and also the fact that because it's significant, that means that if a large excess return value is produced, that will lead to future forecasts of the variance to be high for a prolonged period of time. And so that means that the GARCH model will probably be a better forecasting model than the ARCH model in periods of high volatility. And so after that, again, do your residual tests. So and obviously you're just doing the Lund-Box test for autocorrelation, and when you're doing the ArchLM test, make sure you've determined the optimal lag length first. So again, very quickly, doing the residual diagnostics for our GARCH model. This is for the Lund-Box test. And again, it's good to, well, actually the first one at the 7th lag is actually below 0.05. But as you can see, all the others are significantly above 0.05. So I think on the whole, you could probably say that it doesn't suffer from autocorrelation. Again, go to Residual Diagnostics, go to the ArchLM test. Now bear in mind I've already done this. I know that the optimal lag number that minimizes the information criterion is 1 lag, so I'm just going to go ahead and do that. And as you can see there, observations times by R squared gives us that test statistic and gives us the p-value of 0.9245. So that means we cannot reject the null hypothesis that there are no arch effects present in the residuals, and that means everything's pretty good in terms of the model being well specified. So as you can see there, I've just given you a little print screen of you know, the optimal lag length, minimizing the information criterion again, and as well the final slide in my PowerPoint is just again what I've already explained, that there are no arch effects present in the residuals of my GARCH 1.1 model. It's pretty good. That being said, what we can do next is we can look at something called asymmetric GARCH models. Now there are 2 in particular that I'm going to be discussing. I'm going to be discussing the eGARCH 1.1 model, and I'm also going to be discussing the GJR GARCH model. Normally when you estimate those kinds of asymmetric GARCH models, it's normally good to justify estimating them by conducting a test called the Engel and Ung test. So that will be the subject of my next video, the Engel and Ung test. If the results for the Engel and Ung test work out well, that's normally serves as a good justification to estimate some asymmetric GARCH models. So that's what I'll be doing next, the Engel and Ung test. I've basically explained the GARCH model. Again, I've shown you what to do, how to estimate it on Eviews, and the kinds of things that you should be focusing on when analysing your results. So I think that's everything now. And yeah, so I'll be moving on to the Engel and Ung test now. Okay, bye now.